Hello and welcome to another video. This is part 2 of our Rust for Beginner series. In this video, we will take a look at functions and also learn about concept of ownership, references, and borrowing in Rust. To create a function, we use fn keyword followed by the name of the function and braces, and finally parenthesis for defining the code block of the function. We can pass data to function through function parameters. To declare function parameters, add a parameter name, then the data type of the parameter. It's very similar to how we declare variables. We can add as many parameters as we want. Now we can use this parameter just like any other variable that we declare in a function. This is our function call. And the parameters within function call must match the parameters defined in the function definition. We can also return data from function. For that, we just define the return type, and then we can return the data either by just typing the variable without semicolon or using return keyword and then passing the variable or data with a semicolon.
Note:
Rust does not have function overloading like we have in many other languages, but we can achieve something similar using traits, but that is too advanced for this video. We'll cover that in later videos. So this is the code we wrote in the last video. We also have a lot of code down below. For now, we'll move this code to the comments and then we'll create a menu. So we are trying to create a console application. In this, we'll have a bunch of options, 1, 2, 3, 4. The user can select any of the options and will execute that particular code. So this is the text for our menu. Now let's take our input from the user and then put it into a match to check what user has selected. Now in this match, we can have multiple cases. We will create cases for each menu option, so 1, 2, 3, and 4, and do a default for 5 and exit. Once we have our cases, now it's time to create the functions. So let's move down into our code and create function for each program that we created the last video. So I'm creating very bare bone basic functions. They don't take any parameter and they don't return anything. You can customize these as you want. Try to cover everything that we have learned in the functions and practice it out here. Finally, it's time to pass all the function within the match. And at the end, we'll give a default condition. And we won't do anything in this default condition because we want the program to continue. Now let's run this. Okay, so we have a menu. First, let's swap the values. The swap values happened on its own, so let's run once again. This time we'll select 3 and we entered 45. So we get the sum 1035. To understand the concept of ownership, we first need to understand how programming languages handle memory. Don't worry, I won't dive too deep into the details and try to keep it as simple as possible. Okay, so there are two ways of memory allocation. First is stack allocation. This is fast, not very resource intensive, but the allocation of amount of memory is fixed at compile time. Then we have heap memory. The allocation is a lot more intensive and requires more time, but provides flexibility in amount of memory during allocation. One of the reasons behind heap being more intensive or demanding more resource is that we can't access heap directly. We use a pointer, which is like a variable, which is stored inside the stack, and we use this pointer from stack to get to the heap. So basically, first we are going to stack and then we are going to heap in heap allocation, whereas in stack we directly go to stack. Now remember I said in stack the amount of memory is fixed at compile time. This means that for variables of data type like integer, we can store them in stack even if they are mutable because they consume a fixed number of bits. But that is not the case with the variables of string, vector, or any other such complex data type, as the size they consume may change during the runtime. To make the process of allocating and deallocating memory safe and easy, languages like Python and Java have garbage collector, whereas older languages like C, C++ have Now in Rust, we do not have a garbage collector, but rather have a completely new concept of ownership. This is to specifically deal with such issues and ensure memory safety. The concept of ownership have 3 rules which govern how Rust program manages memory, and these 3 rules are: each value in Rust has an owner. There can be only one owner at a time. When the owner goes out of scope, the value is dropped. Let's look at some examples to better understand the constraints that come with these rules. In this example, the variable s is valid from the point at which it's declared until the end of the current scope. The size of scalar data types is known at compile time, so s is stored in stack. We can copy it, we can pass it as a parameter, we can print it, or we can do both. Everything is fine. But that's not the case if we are using a string. If we try to copy it then print, we get an error. This is because copying data stored in heap is expensive. So now when we try to copy it into new variable, there are 2 straightforward approaches.
1.
Rust does a deep copy and copies the entire data including the data in heap. This will not cause any memory issues, but is very expensive.
2.
Rust just copies the pointer and now we have 2 variables pointing to the data in heap. Now this comes with a problem as well. When the variable goes out of scope, then they will both try to free the same memory. Freeing the same memory twice can lead to memory corruption, which can potentially lead to security vulnerabilities. So Rust selects the third option, which is that it moves the value from the variable s to variable s1. This way there is only one pointer pointing to the heap memory address. The reason we can safely copy between 2 integer variable is because of a copy trait. Any data type that has this trait can do copy without moving the values. For more complex data types, we also have clone trait. Using clone, we can create complete copies, that is deep copies, within heap as well. When we call functions and pass variable as parameters, for basic data types like integer, the copy trait comes into effect and we can use the variable even after passing it as a parameter. But for variables like string, vector, etc., the function that we just called becomes the new owner, and therefore we can't use that variable anymore within our previous function. So this is an example of how we can get the ownership back from the function after transferring it once. In this example, we transferred the ownership of s1 to calculate the length, and then we returned both the length and the value of s1. But there is an easier way to do the same thing. So this code is doing the same thing as previous example, but we have used borrowing in this case. This ampersand signifies that the function will borrow the value rather than taking the ownership of that value. Borrowing works by creating a reference to the pointer which was in the stack, in this case s1. So we are basically using a pointer to another pointer which is then pointing to the data in heap. If we want to change the values, then we can use mutable references, but there are few conditions to do that. At any given time, you can have either one mutable reference or any number of immutable reference. A reference must always be valid. So this is an example of mutable reference. We can use mute keyword with ampersand to make a mutable reference. Now let's take a look at some examples to understand the constraints with the rules of reference. In this example, we have created two immutable references to a string, and then we are printing both the immutable references. So this is perfectly fine, as we can have any number of immutable references within a function. Here we have a string and we are creating its mutable reference and then printing it. Everything seems fine, but the problem is that our string is not mutable. So if the string is not mutable, we cannot create its mutable reference. This is the same example as the last time, but the string is mutable here, so this works. In this example, we have a mutable string and we are creating its mutable references. But the point is, we are creating two mutable references, and at a time in a function we can only have one. So this will give us an error. In this example, we have a mutable string, we are creating immutable references, and then we are creating a mutable reference. This is not allowed. Either we can have any number of immutable reference or we can have a single mutable reference. And finally, we have a similar example as the last one. The only difference is we have printed both the immutable reference before we are creating mutable reference. So as creating a mutable reference after the R1 and R2 has been used within the print line is perfectly fine. Slices let you reference a contiguous sequence of elements in a collection rather than the whole collection. So to slice out a specific string from a different string, we can use the ampersand and then pass the starting and the ending point of the slice. So in this example, rather than giving the reference to the entire string, hello is a variable with a reference only to a portion of string. To be specific, from 0 till 5. And the 5 won't be included, it will be from 0 till 4. Okay, so now we are talking about slice in string. We also have to talk about string literals. The major difference between string literals and string is that the string literals are always of fixed type and their value can't be changed, and hence they can be stored within the stack and therefore are faster than strings. Let's look at this function. This is a function called firstWord. It takes a string reference and returns a string literal. This is basically taking the first word out of a long string. So this is our main function. We have created a string called myString, and then we are calling firstWord function a bunch of times. As you can see, we are passing string literals in first couple of functions, either the entire string as a string literal or just a portion of the string as a string literal. And this works because firstWord requires reference to the string, not the ownership to the string. Next up, we have created a string literal. To pass as a parameter to firstWord, we can pass a portion of this string literal as well, and all of the arguments that we have passed are allowed. Just as we might want to create a reference to a part of a string, we might also want to create a reference to a part of an array. It works the same way the string slicers do. We use ampersand and then we pass the indexes between which we want the data. Now before ending this video, I want to point out a few things in our code. So this is the code that we wrote. Here you can clearly see that we are using a mutable reference. So this is where we were taking input and we didn't want it to move the ownership of A. So we passed a mutable reference to the read line. This way read line could change the value of the string without taking the ownership. And this is just the beginning of where we will be using ownership and borrowing reference, as this is the core feature of Rust. If you don't understand ownership and borrowing, you don't understand Rust. So I'll highly recommend you to go through the documentation as well. And with that, we have covered the basics of ownership. Thanks for watching. Give a thumbs up if you enjoyed this video and do subscribe.